Welcome everyone, welcome to the live stream. Today we're going to be talking about what's in this brown nondescript box. There's literally no branding on it, but this is, inside of this box is a really exciting project. It's called the LH Stinger. So LH is a person known on Discord as, LH, and he designs all these crazy printers, and FYSETC actually decided to pick up his project and sell a kit. So I've left a link in the video description. If you go to that link, you should be able to get $60 off of the kit to celebrate them launching this and going over everything we've got here. But before you pick one up, you probably want to know what's in the box. So let's check it out. Now this is a lot like a Voron kit. This is a lot like a Voron kit where it's just a bunch of hardware. And oops, the box is upside down. Let me flip this right side up. Here we go. Okay, so this is a lot like a Voron kit where you get all the extrusions and bearings to put it together, and then you have to print out a couple of parts to make it work. So yeah, this is all the contents. They give you all the electronics and the hardware. So let's just kind of go through everything. And the premise of this machine is it's basically an Ender 3 on steroids. It's insanely fast, like it's a bed slinger type design, but it's much faster than most Core XY machines on the market. Actually, pretty much all of them on the market at this point. It can do 100K accelerations and 1 meter per second travel speeds. So let's see how they do that. And here's the main trick to how they're able to go so fast. This is the heated bed right here. It's not made out of aluminum like most heated beds are. It's actually a solid piece of carbon fiber, and on the back side is just a sticker that heats the carbon fiber. There's no aluminum or metal on this, so it's extremely light. So this is lighter than like the tool head on most machines. It's extremely, super lightweight, super stiff, and it works well enough as a print bed. And here's the carriage that it attaches to. This is also made out of carbon fiber. So, that's the trick. Basically, it's a bed slinger, but they're using carbon fiber for a lot of stuff. Sorry for the audio and visual quality today. I ran into some issues. Basically, I know you guys don't want to hear about this, but YouTube, if you set up a live stream using your computer, and then you want to live stream using your phone, when you go to your scheduled live streams, it won't let you start it with your phone. So there's this just weird disconnect between their ecosystem, but that's okay. All right, and this looks like the bed surface. So you put the sticker on top of the plate, I think, and this will be what releases the prints. Also, you might notice I'm a little sweaty. I was scrambling to get this live stream started, so, I got a little sweaty. What are you going to do about it? All right, so let's take a look at everything else we've got in here. This is the main board. This is the FYSETC Spider V3. Seems pretty nice. Here, I gotta see what my screen's seeing. I'll take it out of the plastic packaging. You'll probably be able to see it better that way. All right, so personally, I have not been super impressed with FYSETC's electronics and documentation compared to other brands, but we'll see how this goes. I was using some weird niche product that they have, and I was having trouble getting it started. But since this is a pre-assembled kit, they probably have pretty good instructions. So how's everyone doing today? Yeah, let's keep the chat going. What's the weight of the bed? I have a scale. I could probably grab that and see how much this weighs. Just by hand, it feels like about 300 grams. And I'll invite some of the people from the LH Discord to come join us. Actually, I already sent them a link, but I'll just ping them again. And they'll be able to answer a lot of the technical questions. So if any of them join, they'll be able to answer more details about the design. Okay, so let's see what else we've got for the electronics. This is the main board. I'll point this down a little bit so you can see what's on the table here. Here's our power supply. Looks like a 211 watt power supply, pretty small. We've got a bigger power supply here. This is a 350 watt Meanwell, so I'm not entirely sure why it's got two power supplies. I would guess this one might be for the high voltage stepper drivers. Let's see what this says. Yeah, 48 volts. So when you move steppers at high speeds, one of the ways to do that is to just increase the voltage of the stepper motor. That's the easiest way to go about that. All right, then you've got your wires, just all sorts of wires. Those are completely uninteresting, so we won't go over those. Cool. Here's another control board. This one is LH Stinger branded, so maybe this is one that's like specifically designed for the Stinger. Looks like some sort of breakout board. Seems interesting. I'm going to set all these bed surfaces aside, but first let's take a look at the actual carbon fiber we've got here. These seem nicely packaged to keep them from getting scratched. Yeah, so here's the carbon fiber carriage. It's looks like it's water jet. That's a really common way to produce carbon fiber plates, is to just jet them out with water. It's hard to laser cut them because carbon fiber tends to burn, and so does the plastic that you're cutting out. But yeah, looks pretty nice. There's no splinters coming off of this thing. There's a little bit of black dust coming off on my finger here. And that's probably just from the abrasive water jetting process. Overall, they're nice and clean, though. Yay. Okay, so another thing I like about this kit is they actually apply the sticker to the heated bed for you. That was one of the things I was a little concerned about, because when I was looking at the CAD documents, they said you need to stick these together. But having them pre-stuck on there takes out one of those steps that you could easily mess up. I know some people are a little OCD about their sticker placement, so just having them take care of that for you in a nice, precise way is good. Here's a couple more little carbon fiber parts. And, you know, we should just do an overview of the design. Let me go to FYSETC's website and we can take a look at some things. Hit the major bullet points here. So I'm going to switch my screen over to my desktop. Okay. I don't know why these pictures are loading really small. Oh, yeah, there we go. Okay, so let's read through their marketing speak. So LH Stinger, this is on the FYSETC website. I have a link to it. Now it's $800 with the $60 off coupon that they sent over to me. And apparently that's good till the end of the month, but there's a limited quantity. 48 volt power with TMC 5160 drivers. Those allow that high voltage, high amperage motion system. It's got a high voltage board, which I guess that was that second PCB that we were looking at. High torque stepper motors. So these steppers can go up to 2.5 amps, which is quite high. It's got two power supplies. It uses a Sherpa Mini CNC extruder. So that'll be a nice CNC'd aluminum thing. We'll take a look at it in a minute. Fadus Dragon UHF hot end. That's cool. And in this project, you've actually got support for other hot ends as well. Carbon fiber bed and carriage. That allows those high speeds. Lightweight bed heater. Breakout board and wiring harness. Auxiliary part cooling system. We'll take a look at those in a second. And they've got some gigantic additional part cooling fans. They're using 3090 frame extrusions, so very thick and chunky. Normally we use 2040, and that's referring to the number of millimeters that the aluminum extrusion is across and wide. MGN preloaded linear rails. printed parts not included, so I will have to print out those parts, which I don't have right now. But I'm going to put the frame together and just work on getting things organized and ready to print. I think there'll be plenty to do for the next hour or so. Yeah, so this is what the frame looks like. Aluminum extrusion. Max 600 millimeters a second. Yeah, UHF, Dragon UHF hot end. I'll probably end up replacing this with something else. If you go to their GitHub page, they actually have support for a bunch of different hot ends, including some high flow variants like the VZ Goliath. I've got a couple of those sitting around, so I'll probably throw that on this printer at some point. Sherpa Mini extruder, looks good. Then I guess you can put a Raspberry Pi on there. I'll see if that came with my kit. I'm not sure if it did. All right, so that seems exciting. Let's see if they have a link to the... I wish they would put a link to the GitHub here on the page. LH Stinger. We'll look up LH Stinger. Let's look at the GitHub. So, yeah, this is the guy. If you see his little name on Discord or something, that's the guy who designed this for the most part. I think it was a team effort, so there are some people that helped him out. But this thing looks absolutely awesome when it's finished. I actually took a look at one of these in person at Rocky Mountain Rep Rap Festival. It was quite fun. So this gets into a little more of the tech specs. 1 meter per second maximum speed, 10,000 millimeters per second acceleration. And these are the frequency responses. This is basically a chart that you'll look at that tells you the quality of the frame. So if the frame is stiffer or if it has multiple modes of vibration, this graph looks really messy. Ideally, you want it to vibrate at a single frequency with a really narrow peak, and that's what you can see here. So this type of behavior is very easy to compensate with in terms of applying an input shaper to the machine. So you get great quality at high speeds. And yeah, I really like the project because I've spent a little bit of time chatting with LH and the team behind this project, and they really know what they're doing. So just nice to see when projects are competently engineered. Okay, let's get back to looking at the kit. I'll check on the chat, make sure you guys are doing all right in here. Lemur Hayes, okay, LH is in the chat, so if you have any technical questions, I definitely hit him up. So, cool. Where does the AMS go? King Sidorak, you're such a troll. I'm pretty sure you could throw a enraged rabbit carrot feeder or one of the other open source options for multi-material unit on here if you wanted to. Okay, let's look at some more of this hardware. So, this is, I guess, genuine Gates belts. I don't have a way to test if they're actual Gates belts, but they appear to be. I at least have it printed on the side. We've got a bunch of pulleys here, and something right here is quite striking. I'm not exactly sure why they're using these gigantic pulleys. I think it's probably part of a gear reduction for the Z-axis. So maybe this will be like a 10-to-1 gear reduction so that the belted Z will work properly. Yeah, so, all right, let's take a look at some more goodies here. I'll just display all of this stuff. So we've got fans up here. These are probably for the electronics box. Here's another little fan. Then there's this special wiring harness cable. I love this. All right, I'll talk about it in just a second. We've got some smaller tool head mounted part cooling fans, just your typical 50-15 blower motors. I'll get them out of the bag here so you can see. 50-15 blowers. Hopefully these are nice and quiet. I appreciate a quiet blower fan, but we'll have to check those out. And then here's the gigantic fans for the auxiliary part cooling system. those should be able to keep up with the high speeds of the Sprinter. This looks like a couple, whoa. These are like really thick foam. Like, it almost feels like rubber, but I think it's a foam. Probably for like the feet or something. Okay. More custom wiring. And more custom wiring. So, and then power plug. And here's your linear rails. So I would really like to see this design scaled up to be even larger. Right now it's I think it's a 200 by 200 millimeter build area, which is enough, don't get me wrong. But yeah, it's really built for speed. Like, this thing is going to be insanely fast. But I don't see why you couldn't just increase the dimensions in X, Y, and Z here to make things even bigger. Okay. So these are FYSETC branded linear rails. We'll see how nicely they slide. So they have preload, which increases precision, and they slide pretty nicely. They don't really get stuck anywhere. And they're preloaded, so cool stuff. All right, so FYSETC must have a decent supplier for these things. They're not like gritty or dirty or anything like that. However, they do recommend cleaning and lubricating them. On another machine, I might just ignore that kind of advice. However, on this machine, it's going over like around a meter per second. So with those extremely high speeds, you're going to need to reduce friction as much as possible. So if that means going in there and cleaning them and applying some lubrication before I get started, that's not that big of an issue. This printer looks dangerous for my wallet. It's not that bad. It's you know, $740, and then I imagine you'd have to buy a couple more pieces to get it all the way put together. But this kit seems very inclusive. Like, pretty much everything's in here. And then you got to print the parts, obviously. Now let's talk about wire and cable management. This is a place where I think LH did a great job on this design. So one of the parts that I hate about building custom printers is you have to build your own wiring harness and get all these individual wires and you know, wrap them all together and send them out. And then you have to plug everything in individually on the main board. With this one, it looks like you've got one main connector here. This is probably for the heated bed. And it's just got kind of a standard Molex. It almost looks like the old school fan connectors. If you ever built a PC back in the 90s, then you'll recognize this kind of connector here. It seems pretty nice. And then here's this one, which looks like it's an even bigger cable harness here. This looks like the type of cable that you would get on a ATX power supply. And I actually was thinking about producing my own product that used this type of cable because it's so inexpensive and it's reliable and it is able to carry all the power that you need for a 3D printing application. It's nice and easy to plug in and unplug. Like, if you look at all the modern printers from Bambu Lab and Creality, if you look at the actual connectors on there, they're like these little ribbon cables and crap that's just going to break as soon as you try to unplug it. So using full-size connectors here, the right type of connectors that are going to be durable, I just think that's awesome. Yeah. So what do you think the upper limit is for the speed of this machine? I imagine you'd probably be able to go over 1 meter per second if you really wanted to push it. I think Lemur might have some explanations there. Like, if you threw some servo motors on there with maybe thicker belts or larger diameter pulleys. Okay, so let's look at the aluminum extrusions that they've got in here. This is the first hardware kit that I've got from FYSETC. And these seem really nice. I'm not sure what, like I can't evaluate the flatness of these. I can estimate it by doing a couple of mechanical tricks here. But there's no aluminum shavings on here. And these are, you know, just a nice flat black color. Even the ends have been either painted or anodized. They're not wrapped in protective film, so they'll probably be a little more prone to getting scratched in transit, possibly. But they're nice and well packaged in there, so it doesn't seem to be too big of an issue. And there's no like excessive aluminum shavings in there. Sometimes I'll buy aluminum extrusion and it's like they finished machining it and they didn't bother like blowing off the extra chips. These have been cleaned and painted, so that's nice. Also, the ends of this have already been tapped, so you don't have to do that yourself. Cool. So it looks like we've got 2 segments of 3090 aluminum extrusion and 2 segments of 3060. And these are much stronger than a 4020 aluminum. Like if you look at a normal Ender 3, the extrusions are just a little bit wimpier than this, and that's going to mean the frame is more easily flexed, which reduces the vibration performance. Basically, the fundamental frequency of the system gets lower. So when you stiffen everything up, you make it behave more like just a solid chunk of metal that's infinitely stiff, which will give you the most mechanical performance in terms of dynamics. Okay, so here's a trick that I like to do to evaluate flatness of things. The most common type of misalignment with these, if they're not perfectly straight, will be curvature. So like if these were curved, then you push them together, they're not going to fit together perfectly. If they're both curved like that, you push them together, they're not going to fit perfectly. If you put them like this, then they both have the same curvature, then you won't see any gap. So let's just see. No gap there. And then if I rotate one of them 180 degrees and go like this, not really any perceptible gap there either. Yeah, so these are pretty straight. Like, I don't think you'll have any issues, or at least I won't have any issues with this build with the extrusions being curved. Okay, let's take a look at the remainder of the box contents. We're going to finish up the unboxing here. Okay, so the aluminum extrusions were in these empty cells up here. I took them out, so this will be a little bit lighter. And let's go over what's in this portion of the box. Oh, nice, Philip, thanks for the donation. Your channel incentivized me to a more technical content for 3D printers. I appreciate it. Thank you. It forced you, oh no, it incentivized you. Well, that's good. I appreciate, you know, I think my audience tends to be a little more technical and just liking to get a little more into detail. I don't print a whole lot of like figurines and stuff here, and I don't, but I like talking about 3D printer technology and stuff. So let's see what's in this little box here. We've got a input shaper nozzle thing, so I guess this gets screwed on into the, like in between the nozzle and the hot end. So you attach this accelerometer directly to the hot end. And the reason why you do that is if you actually look at the hot end as a whole, you imagine it accelerating and moving back and forth. And it's like, okay, I can measure that with my input shaper. But if you actually look at things, I have a whiteboard behind me, so let's see if we can actually draw up here. So let's say you have the hot end and you're extruding plastic. The plastic is coming out right there. And here's your x-axis. As you accelerate this thing back and forth, that's showing up? Cool, okay. As you accelerate this thing back and forth, the hot end can actually rotate and flex in other ways. So by having the nozzle accelerometer, by mounting the accelerometer directly to the nozzle, you're getting the closest measurement to what the printer is actually doing where it's extruding plastic. So having it right there, I think, is the best spot. Okay, off-topic question for you. Do your kits work with large XY machines like Neptune 4 Max or Cobra 2 Max? I don't know. Hey, Rack Robotics, good to see you. I'm not sure whose kit Awestruck is talking about. All right, so we'll keep on going. Casual Research is complaining about the price. Well, Casual Research, I don't know what to say there. If you can't afford the $800 printer, then nobody's forcing you to buy it. But I still think it's cool, and it's worth taking a look at because they made some interesting design decisions on here. We got 2 more little pieces of extrusion, and then stepper motors. Let's take a look at little steppers here. Um, 1.8 hybrid stepper motors. So I've been doing a little bit of learning about different types of stepper motors. Apparently hybrid stepper motors are more expensive. This type here. And a hybrid stepper motor basically has kind of mixed properties between a stepper motor and a DC motor. So DC motors are optimized to spin at high speeds. Stepper motors are designed to spin precisely at low speeds, and hybrid stepper motors are kind of in between, where when it's running at higher speeds, it's easy to have the machine moving fast. So when you go into designing a machine like this, you really have to get into the details of every engineering decision. And based on my conversations with LH Lemur Hayes, the guy has put a lot of thought into this machine in terms of how to get it going as fast as possible. So if these are hybrid stepper motors, I have a reason to believe that they're hybrid stepper motors for a reason. And I think they're a little bit more expensive. So obviously you don't want to make your build more expensive for no reason. That's like a general truth about engineering. So we've got 2 4042s. These are identical in size to your Ender 3 extruders. Like if you had an old Ender 3, you had that old Bowden extruder system, these like larger stepper motors are what you would have there. They feel quite a bit denser than other stepper motors that I've played around with. Then we've got, we've got 3 of these in total. So I assume 1 is for the X, and then 2 are for the Y. And then these 2 smaller guys are probably for the Z. So we'll take a look at that. I'm probably wrong, just as a heads up. Here's your extruder. This is the Sherpa Mini. There we go. I'm on a Mac and Siri just thought I was talking to it. Go away, Siri. I wish there was a way to disable that. Anyways, Sherpa Mini extruder. Seems like a nice, lightweight, skeletonized design. I don't know what's in here. Oh, these are our stepper motor drivers. I'll take a close look at those in just a second. Here's a big bag of aluminum brackets. So these are the type of cast aluminum bracket that you'll use to join pieces. Wait, are they aluminum or are they plastic? No, these are cast aluminum. So these are aluminum pieces that are, that scared me. These are little aluminum pieces that are used to attach your frame together. And the reason why you want to use aluminum to attach frame pieces together is because usually the weakest or most flexible part of a system is going to be the joint in between 2 beams. Like each individual beam here is incredibly stiff, And the weakest part is probably going to be the joint between this and the other piece. Unless you like welded it together or something, that's probably going to be your weak point. And if you're using 3D printed components to join these together, you're throwing away a lot of the stiffness of these bars because plastic is very flexible, aluminum is not. Now, an interesting thing in terms of the mechanical engineering and material science about these things, this can be made out of a low-grade aluminum and it will still be just as stiff as it'll still be just as stiff as a high-grade aluminum. So this might be made out of, I have no idea what it's actually made out of. It's probably a pretty standard alloy. But if you made this out of aerospace grade 7075 ultra high strength aluminum, it's actually not going to make the frame any stiffer. It'll make it stronger, but stiffness comes from the actual material being applied. Strength comes from that material resisting plastic deformation. That's a topic I could get into on another day, but that's like one of the cornerstones of mechanical engineering. Okay, what else do we have? We have a gigantic bag of fasteners. I was hoping this would be a little bit easier to put together than a Voron, and maybe it will be, but this bag of fasteners is quite beefy. And maybe that's just because the nuts for attaching parts to this 3060 aluminum are much larger, so every nut that goes onto this machine is a little bit heavier. And that might be contributing to the weight. That part looks like a die cast, which is generally Zimac alloy. This part will be as good as aluminum with its thickness. All right. Well, thanks Rack Robotics for coming in with the well actually. So is Zimac, it's like a zinc aluminum magnesium alloy? Stratasys is the bamboo killer. Well, they might be taking the legal route to killing bamboo, but I think Stratasys knows what's good for them in terms of having money in their pocket at the end of the day. So it probably doesn't make sense to completely ban. You know what? Let's just not talk about that today. Today we're talking about cool open source stuff. We don't have to be burdened by the corporate IP drama that happens with privatized 3D printer designs. Okay, we got a couple big brackets. These are probably your main brackets for holding the X and the Y axis, X and the Z axis together. I don't know. The part that stands up, that's like the tombstone is what I like to call it, because it's the part of the printer that's sticking up in the air, and that's what's going to wobble back and forth as your primary mode of vibration, which is what you want to stiffen up to make the whole machine stronger. Okay, we got zip ties, we got clippers. I think the machine runs clipper as well, so we got all sorts of clippers on here. And some really nice Allen wrenches. So we'll check everything out. Okay, time for me to get my bearings and figure out what the heck I'm doing here. We've got this gigantic roll of, what is this type of tape called? Kapton tape. Not sure what this is for. Maybe it's for the bed coating. Haven't played with a roll of Kapton tape that large in a while. Okay, so what do we do next? What do we do next? I really appreciate Lemur Hayes being in here to give some background on the printer. I wasn't involved in the design of this machine, but I've been kind of keeping my eye on it, and I think he's done some cool stuff with it. Especially that carbon fiber bed. Like, that is very smart. And one of the advantages of the Core XY, one of the advantages of the bed slinger motion system is you just have you basically have two objects moving. So one moving this way, the bed moving front and back, and then the x-axis moving back and forth. And that really isolates those two axes away from each other. Versus on a Core XY machine, you have a bunch of coupling between the X motor and the Y motor, and like motion on one will cause motion on the other when you're moving at high speeds and having all this vibration and stuff. So I do think the bed slinger type design is going to be more suitable for pushing the absolute limits of print speed, but there is a time and a place for Core XY and other types of motion systems, especially when you get into really heavy prints. So if I print a full kilogram of plastic onto this build tray, even though it only weighs like 300 or 400 grams, it's going to weigh 3 times that by the end of the print, which is going to influence the print performance. Okay, so there's no instruction manual. It's all online these days, so I'll have to pull that up on my computer. Let's just take a quick peek at these stepper motor drivers. These, they look a little bit different than your normal stepper sticks. So you can see the individual little MOSFETs on there. And then on the back side, you can see a little, I guess that's some kind of MOSFET driver chip. So that's the big difference between the, I forget what the word is, like the standard stepper motor, the standard stepper driver that everybody uses. It's like the TMC 2046 or something. The main difference between those and the TMC 5160s is that the 5160s have external MOSFETs, so they can handle much higher currents and voltages. I have not checked, so Ed Evans is asking how much my 4-headed printer, how much plastic it puts into the air. When I have my HEPA filter running, it literally brings my particle counts close, like pretty much to 0. So I'm not too worried about it. Plus I usually run it in another room. So it's kind of a non-issue. If I turned my HEPA filter off, then I imagine that I'd get massive amounts of particulate buildup. I'm actually not sure if it would cause more or less particulate than a normal printing operation, because it's the hot ends that I'm using on there are running at pretty low temperatures, and the emissions are basically exponentially increase when you increase temperature. So, you know, running those as cold as possible is one way to reduce the amount of particulate emissions. Okay. So, time to start the build. I think today I'm just going to start by assembling the frame and basically just figuring out what to do with all these parts. I mean, just look at this mess I have on my desk right now. It's quite impressive. So let's get started. Is anyone doing anything good this nice summer Saturday? I went to a farmer's market. I have delicious fruit to enjoy. So I'm gonna have a little snack. While I organize these parts. Here's one box I didn't go over. It looks like there's like some springs and motor shafts, some magnets, and some Bowden tube fittings. Now this is a direct drive printer, so you're not going to have to worry about Bowden tube issues, but I'm guessing those Bowden tube fittings are to help manage the filament path. So how do live streamers normally handle eating? Do they just not eat? Because I can't do that. I gotta eat every like 5 minutes. I'm just having a little snack. Hello, 3D Medic Vance. I'll try to keep up with the chat a little bit as I go. About to go clean your gutters. Nice. Hopefully it's not too hot and sunny out there. All right. So many parts. I got, okay, so I've been getting a lot of advice on how to clean these linear rails out. Personally, they seem fine to me, like they're quite nice feeling. But if the actual designer of the 3D printer themselves is telling you to do something, you should probably do it. So I will clean those out before I get them fully installed on here. Oh, you're in Australia. You know, I was going to stream last night, but I think it just works out a little bit better Saturday mornings, because then some Europeans can join us too. That's some chubby apple and fans and aluminum profiles. Nice. This is not an apple, it is a peach. But jeez. Okay, let me just finish eating this. Okay. Time to get my bearings here. Not my linear bearings, but my metaphorical bearings. And I need to open up the assembly guide. So I'm going to go to the LH Stinger website, the GitHub. I'll try and set up like a picture-in-picture thing so you guys can see what's going on my desktop. At least a little bit. Okay. What do you guys think? Is this good? Yeah. No? Here, how about up like this? I'll get it. I'll get it. Here we go. Okay, how's that? Now you can see what's going on my instruction manual here. Is there an assembly guide that I can check out? I have the CAD viewer open as well. Okay. Open the model browser and properties window. Oh man. Open the model browser and properties window. Okay, where's the CAD viewer? I just promoted LH to what do you call it? The please don't place the extrusions over the wires. Okay. All right. I'm sorry for doing that. The wires, I'm sure, are irreparably damaged. All right, excellent. I will open up the Discord. Okay, I'm gonna start losing things really quickly if I don't reorganize a little bit. Okay, so wiki/assembly guide. All right, so let me get most of this in frame. Here's the assembly guide. Okay, I don't have the 3D printed parts yet, which is because I'm lazy, and I will get those later. But I think, like if I do this part, that'll take me enough time to at least, be able to understand the design a little bit better. And I can just set it on my desk and look at it for a while and kind of understand what's going on here. I think one of the most time-consuming parts about these 3D printer builds is just familiarizing yourself with the design. It's not completely obvious how everything goes together, so yeah. Okay. This is looking pretty good. This part's a little complicated, these Z-belt drives. Now, this requires a couple 3D printed parts, so I'll take care of that a little later. Interesting. So yeah, the documentation here seems pretty good. I think this is LH's doing and not FYSETC's doing. So FYSETC, they can do a great job manufacturing things, but when they write their own documentation, it's not always great. The fact that we've got some documentation written by someone who's proficient in English is a good thing. Nice. Okay, yeah, I'm just getting like I'm speed running through these so I can kind of understand where I'm going to end up going with this eventually. Once I get it put together to this point, things will start getting pretty cool. Looks like the original design he was using LDO motors for their supplier, but obviously with FYSETC they have their own supply chain, so they're not going to use the same motors. Okay. That doesn't seem too bad. I mean, the whole idea behind the Ender 3 style aluminum extrusion frame is that it's something that most people are familiar with, and it's just like simple and sturdy, easy to build. Okay. I will start by preloading my square T-nuts. I'm going to hop on the live stream so I can see the chat on my phone. And that way I don't have to pull it up on my desktop screen there. Personally, I'd probably prefer the 235 by 235 bed, but I can't complain because FYSETC sent this over for free, so that's very generous, and I like the design. Oh, my head's being... Here we go. Let me move over to this side. Okay. Let's do this. So, looks like all right. Ooh. Do your stretches before a long day of assembly work. I'm gonna make sure my in case you were wondering why I was all sweaty at the start of the stream, I was actually a little stressed out because the stream wasn't starting properly. Yeah, the good old YouTube wasn't letting me start the stream using my phone. So now I'm using my computer, which honestly isn't that bad of a idea, because now I can show you the desktop and stuff. Okay, time to clear off most of this stuff and get started with the frame assembly. So here's our top extrusion. Here's our bottom extrusion. Here's our Y extrusion. I'll get more of this out of the way here. Y extrusion. And I'm already liking the way this looks. Like, just look at it. Look at it. It's like built like a CNC router. Very cool. Okay. And then these two go like this. And then this goes across the top. So it is time for the nut insertion phase of this project. Looks like I need the M3, M5, and M6 sizes. And these are the square nuts. So has everybody watched Dune, the second part? Dune 2, I just watched it last night. Thought it was pretty good. Alright, M5. And we need our M6s. I know I'm late to the party, but it's free on HBO Max, if you have HBO Max. I need to drop those Amazon links for HBO. But it's pretty interesting. Okay. Alright, so time to start loading up these nuts. Okay, note the rails with hardware attached have to be inserted before closing the end access. Got it. So let's start out with the M3s. These are the goofiest looking nuts I've ever seen. Look at these. You're gonna put a little M3 bolt into that hole and have this giant nut. I mean, it actually doesn't matter from a performance perspective, but I just think it's a little funny. So we'll put 2 in. 4 altogether in this aluminum extrusion. Watch Doom 2. It's Dune. I always struggle with squaring the frame. Yeah, I have a 1, 2, 3 block. I don't know if that'll be enough for this. It'll probably be fine. I'm okay with 3D printers not being perfectly square. Like, sure, all the parts will be slightly crooked, but generally when you design parts for the 3D printing process, you add a bunch of extra tolerance anyways. So having them be 0.5 degrees off, it's not gonna be a big deal, in my opinion. Okay, so we got the M3 nuts settled. Now it's time for the M6 nuts. So I need 24 of those bad boys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, 20, 24. Okay. I like these shiny metal nuts. Okay, so we will put 2 in here. We'll put 2 in here. Oh. Two in here. On the top along the back. And then 2 on the opposite side on the bottom. And 2 in the front and 2 in the back. So I'm just building this entire thing like in this first image on the left. They add additional views in there for people with poor spatial reasoning skills, but I think I'll be fine with just the first image. So I'm assembling this whole thing with the printer facing me. I already got something wrong, so let me flip this 180. Alright, so... Alright, then we'll get... two on the left. I've upped the ante for no reason by calling people out. Now I have to get it right. Okay, and 2 over here. And then 1 on the front of each of these. Or I guess it's the back. So the way that I'm looking at the printer right here is I'm in front of the printer. You guys are looking at it from behind, because you're weird like that. Okay, the block will come in handy for the Z-pillars since the rails are facing each other. Okay, yeah, that's what I heard. It's an interesting setup that has rails on both sides opposite each other. So if they're, twisted or skewed or anything, that could mess with things a little bit. Okay, so I have 4 of these nuts left. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5. There's only 20. Okay. Oh, am I getting this right? 1. Oh, no. Oh, okay. So you need additional views because some of them are obscured here. Are they? Yeah, so like over here I can count 1, 2, 3, 4, 5. And over here I can only count 1, 2, 3, 4. So some of them are obscured, so we have to rely on other views here. So I think the part that I missed is there's 4 under. Yeah. Okay. So there's 4 underneath the frame instead of what I thought was. 2. But still, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's only 22. I counted out 24, and it says 24 in the documentation here. But there's only 22 orange nuts in these pictures. Yeah. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So the whole design is, we got to start over. Okay, well, I just have 2 extra nuts here I'll set aside for later use. It's not the end of the world. Let's move on to our M5 nuts. We just have 2 in the front and 2 in the back of the y-axis. Looks like they gave me 1 spare here. The other huge advantage of using these large extrusions is that it requires less fasteners to put things together. Like if you're using 2020 extrusion, then you have like an 8-bolt pattern that provides a certain amount of strength. You can probably get the same strength with this using 4-bolt patterns because you can use larger bolts and the extrusions naturally spread the load better since they're stiffer. So the larger extrusions basically equate to a faster assembly time, which I am all about. Use printed parts to hold the T-nuts in position. Okay, so I don't have that. So we're just going to ignore that bit of advice for now. Yeah, we're just going to ignore that for now. Okay, so frame squareness. Okay, it's important the frame is squared, apparently. Huh? Okay. So, at this point we need to get some brackets and start bolting things down. Where are them brackets? Where are they? Where'd they go? Okay, we got these little guys. I think they go underneath on both sides. I'm going to get some more snacks because I can't go 20 minutes without eating. So let me get some more food. I'll be right back, guys. Okay, we're back. Food attained. Okay, time to get some bolts out to go in these nuts. Button head, oh no, button head screws. Okay. Side, oh man. Huh. Okay, here goes. That's a lot of parts. Hold on, I need to prepare myself for this. Oh, I need to check which ends are tapped. Okay. Yeah, I can see how that matters. Okay. So it looks like the only part where the tapping matters is on this bottom piece. Because if we get a little side view for you. Basically there's two tapped holes right up here, and then in the back there's an untapped hole. So since the tapped holes are only on one side, I need to make sure I have them the right side around. So do the tapped holes on the bottom extrusion need to be towards the front or towards the back? Okay. Is this a front view? No, this is a back. This is looking back from the lower back side. I think I've got it right. Yeah. It is a little difficult to tell the front and the back on this printer, but I think I got it. Okay, so I need to find all these little pieces. Fortunately, it doesn't require any printed parts since I don't have any of those right now. Okay. So I need two of these. I need two of these. Cast 90-degree corner. No tabs. Okay. Okay. Got two of these. And then two of these, cast 90-degree corner, 6 slot. I don't know why it says 6 slot. Maybe it's an M6 slot. I'll get two of these out. Two of these. Okay, I've got, that accounts for these top 4. Now I need T-nuts square M6 5. I think those are already in the printer, right? One, two. Huh. 3030 M6 5. T-nut square. Okay. I mean, M6 3030 T-nut square. Yeah. Most of those should already be in the printer. I have a couple extras here, so if I need more, I can just grab those. So I'll ignore that portion. Now I need to get the washers. M6 washers. What are the odds they forgot the M6 washers? I'm guessing it's pretty close to 0. All right. I'm gonna... These are shim rings. I don't think these are washers. Maybe these are the M6 by 12 by 1.5 shim rings. This might be what I need. I mean, it matches the dimensions to a 1/10 of a millimeter. But maybe they couldn't find washers in the exact size that they needed, so they just got these and called them shim rings. What's LH's opinion? Check the CAD for the stage. The listing is just to prep parts so you can identify them in the CAD. Okay. I'm just going to assume that these are the washers that it's talking about. So we're just going to go ahead and use these. M6 by 12 shim rings. They're like same dimensions basically. Like M6 by 12 by 1.5, but it's 1.6 on the instructions here. We're going to call that close enough. Screw button head, M6 10 millimeters. All right. M6. What this assembly is telling me is that LH has like a gigantic plethora of different fastener options sitting around at his house. So he didn't need to use the same M3 by 10 fastener on everything. All right, so I'm looking for the M6 by 12. Those should be larger. M6 by 12 socket head cap screws. Okay, I need 2 of those per assembly. So we'll set those aside. You know what might actually make this a little bit easier is if FYSETC, a lot of companies will put these bags of fasteners. I don't know if you can see them all over here. A lot of companies will take these bags of fasteners and put them together in like a sub bag, like this is for frame assembly and it just has all the fasteners for frame assembly. Could make it a little bit easier technically, but we're just gonna keep slugging through it. Let's see, M6 by 10 button head cap screws. There we go. M8 by 16 button head cap screws. All right, here's those. M6 by 14 and M6 by 12. So M6 by 14 countersunk. We will find them. M6 by 14 flathead. So they call them FHCS. Flathead cap screw is what they're normally called. They're called countersunk in the description. So you just have to know the difference there. All right, preloaded T-nuts are included in the tables above. Got it. So the T-nuts here have already been loaded into the frame at this point. All right, it is time. So Yeah, I can see where having the CAD open will help here. Because you don't see the other side of this. Wait, let's see. Does it say up here? No, it doesn't specify like which fastener goes in which hole. So we'll figure it out. One of these, you know, the flathead obviously goes in these countersunk holes. So I can load those up. I'm gonna get some tissues because I don't like having grease on my hands anymore. Okay, so it is time to open the CAD. I think LH might have sent it to me. Fusion. Okay. Okie dokie. Yeah. All right. So we'll just go to this website. All right, so there's a really nice URL that you can go to if you want to open up and watch along here. I'll actually paste it into the video. If you want to look at the CAD model, like especially if you're looking at this as something you want to try yourself, you should probably look at the CAD and see how it's built. Okay. So we're going to figure out which screws we're going to install here. In this case, we want to look at this little area. So it's button head cap screws on the bottom, button head cap screws on the bottom here as well, and button head here. Where does the where are the regular screws going in? The bolt, socket head cap screws. Okay, right here. Okay, so the socket head cap screws are going in the slotted hole with the washers. So with that amazing information, I think we know what to do. I'm going to flip this around a little more and look at things. This is interesting. So I assumed that all the holes on this bracket would be used, but this one's left open. Maybe you could use that for attaching something else or zip tying this to the ground or something. All right, I think I get it now. So let me load up these two. Yes. Yes. Yes, yes. Wait, that doesn't fit. Okay. There we go. I don't know if I'm doing this right. We'll figure it out as we go. Okay. This one. we'll get that going. I need Allen keys. Oh yeah, LH was also showing me a way to just look at the frame. So yeah, that just hides a bunch of the additional components. It just lets me see what I'm working on. But I don't mind looking at everything. I can kind of see around. Okay. I wouldn't mind assembling these as sub-assemblies first, like getting the left and the right hand side attached with all the brackets and then putting it the rest of the way together, but it's not a big deal. I'll figure it out with my tremendous intelligence. Properties, oh, okay. Okay, so if I can eyeball what screws are, but if you go here and look at the properties, yes, this identifies the exact type of screw, so that's nice. Everybody does their CAD a little bit differently, so this seems to be pretty well documented though. Okay, these two. I guess I'll use both of those in a minute, but I will attach this guy right here using the socket head cap screws. Now, I don't know how I'm supposed to drive these bolts. This is the largest Allen key that I had included in the bag, unless there's something I'm missing. Like here's the bag of tools that I had. These are all the smaller Allen keys. Maybe there's a separate bag that has the larger ones in there. I will take a look around. Not seeing anything. I need a bigger table? Nah, I can use more of the table if I want to. There's more table around here. Maybe it would be smart to spread out a little bit. Okay, so we'll put this one down here. You know, it might actually make more sense to assemble this on its own, flat against the table, like laid flat. So I'm going to do that actually. That's going to represent the most ideal way to do this. Don't judge my organization skills. Everything is very organized here. So I can just take this, lay it flat like so. Take this like that, and flip this like this. Hey, that works great. Now I don't have to fight gravity so much. Very nice. Okay, let's keep going. All right. Okay, that bolt that I just tried to install was the wrong size. Ah. Ah, yes. Okay, so that bolt that I'm trying to do right now is an M8 by 16. I have an M6 right now, so that is obviously not going to work. Let's switch up to the M8s. Yeah, there's no driver, I think, in the bag for this. Unless it's like inside one of the boxes. So I'll have to get something to do this. Let me look for a driver in my toolbox. Oh yeah, they don't have the big hex key. It's not a big deal. Now, if you're like me and you keep all the tools after you're done putting IKEA furniture together, then this will be no problem. You'll have probably about 10 of these sitting around. All right. And this is why we get the test units, so I can be a human guinea pig for these companies. They can figure out what they need to fix. And hopefully I can make some good content while we're at it. Okay, the other thing is that the bolt doesn't fit through this hole. I don't know if I need to drill this out or if there's like a special drilled out version that's included over here. What do you think, LH? Does this need to be drilled out to fit this bolt? Because this threads in, yeah, this threads in just fine into the end of the extrusion, but the holes here don't appear to be big enough. Derp. What do you think? I have calipers I can get, so I can actually measure things instead of being like, looky. I have the chat. Okay, where are I see the calipers. I got some tools here that we might need to use. Okay, so right now I'm trying to install this bracket right here, but if we zoom in on the CAD model, and this is a M8 by 16. Yes. Okay, so this is an M8 bolt. Hold on, let me get this right side up so that you dyslexic people might be able to put it together. Okay, so that's an M8, right? This hole that it's supposed to go into, right here, measures 6.32. So this needs to get drilled out to fit an M8 bolt for sure, unless there's like some special modified ones. Oh, okay, check the other brackets to see if there's one drilled to M8. I will take a look, see. Ah, okay. Here. So these are the ones that have been drilled out. You can see the aluminum colored stuff in there. Cool. All right. So that's not disaster averted. Whew. So John, I'm not sure if I'll put tube on it. I have a lot of other hot ends to take a look at. I have an extra tube, definitely, that I might throw on there. But I only have a tube air, which as we know is the least tubey tube. So I don't have any spare conduction sitting around since they're all being used on my large printer. Okay, there we go. All right. So that wasn't a problem at all. We just needed to find some things. Okay, what next? What next? Time for the flat head cap screws. Yeah, okay, I actually do like the way this is set up. They need to plaster the link to this this CAD model everywhere because it's very useful for getting the assembly going. Weasel box, I would recommend these Mitutoyo. If you want to buy a good pair of calipers, they're just like the best that aren't insanely expensive. And they're about $100, so they are kind of expensive. Like, I wouldn't consider that to be cheap at all. But I've had these calipers for 3 years, and the battery has lasted, you know, like it basically doesn't use the battery. I'm not sure how it does that. And they're very precise. Like every time you close the calipers, like you know, it's open, and then you close it. Bad example, I guess. It goes back to 0 every time. Versus with a lot of other calipers, they're really squishy, and like if you push on it, it'll like go past 0 and stuff. But you know, these go back to 0. There we go, every time. Plus or minus 0.01 millimeters. So really good precision. And if you're measuring things like bolts or the diameter of a piece of filament or anything like that, you need that high level of precision and repeatability, which you get with Mitutoyo that like your average $20 calipers tend not to have. And their batteries die every like once a year, and you have to replace them, and it's all annoying and stuff. But yeah, Muratoyo, could definitely recommend. I'll drop an affiliate link in the comments because I love shilling Muratoyo. This is the exact one I bought in 2020. So. I've actually dropped them quite a few times too, and they seem to be holding up. Mitutoyo affiliate link. Boop, boop. How long does it take for Mitutoyo batteries to die, TNX? Because I've never seen it personally. I'm not calling you a liar. I'm just saying. At one point, I think I dropped them and they lost their origin, and they were like blinking, and I didn't know what was wrong with them. Apparently, all you have to do is hold the origin button down and it resets itself. But I thought the battery was dead, so I bought some new batteries and I replaced it, and it still didn't fix it. And then I measured the voltage of the batteries using a multimeter. And the battery of the old Mitutoyo one that came with it was a higher voltage than the brand new one that I bought on Amazon. So I think these actually recharge batteries somehow. Yeah. Dial calipers work just fine too. That's how they used to do it in the old days. Nothing wrong with that. Except they have a little bit of backlash sometimes if they're like really well used. Let's keep it going. Okay, so I didn't even have to use my drill, which is good. I did have to get this extra Allen key, but it's a standard size that comes with a lot of IKEA furniture, so you know, you'll probably have one of these laying around. Okay. This one goes in here. Ah. Interesting. Yeah, these ones that I'm using right now have their original batteries. I bought them in 2020. You know, that's possible. That would be really cool, actually. So Casio, I have a Casio watch, and this is solar charging, so I don't have to worry about the battery dying. But that would be really cool if there was like a, you know, like a fancy, ultra durable, tough guy calipers that automatically charged through the LCD screen. That'd be insane. Regular LEDs will produce a minuscule voltage under light. Yeah. There are Mitutoyo calipers with solar panels. Okay. Interesting. Yeah, I kind of want one now. Because, like, I don't know, like with this Casio, it has a built-in light and everything. So you can have it light up and do all sorts of cool stuff. Maybe even have, like, some low power draw Bluetooth stuff going on. So there could be a lot of room for innovation in calipers, like have a smartphone app and be able to data log and all that stuff. But these are like very traditional tools. The people who end up using them are very old school, so they're not really pushing the industry to come out with new features for it. Okay, so we've got this one in place. I'm just gonna roughly get everything tightened up. I'm not gonna really torque these down until I get everything in place and ready to square it up. Okay, so that's all good. Time to attach these inside brackets. I just need to put these little things together. Hey, Jerry Smith. Hello, everyone. We've got a nice little chat going on in here. Make sure you don't get too bored while I put this thing together. Okay. Okay, got that one in place. I'll flip the next one up so you can see what's going on here. I know you guys get bored very easily. Make sure you preloaded the two nuts in per side in the middle channel at the back. Yeah, I did. Oh no. Huh? Okay. Okay, I can do this. I can get those preloaded. I'm confused. So, you know, I think probably the best thing to do is just use this CAD model for everything. This is just wonderful. So I preloaded these into this slot up here. I don't know if you can see. I preloaded 4 into the bottom, but I think I put them in the wrong channel. So I think these need to go down 1 row, which means I just need to go like this. Ah, crap. Okay, so take these out. All right, that should do it. Oh no, you don't like the SV08? I kind of liked it. I mean, it's the cheapest machine that's 350 by 350 and high speed and somewhat open source. And the time savings for putting that together compared to a Voron are quite remarkable. I'm working on a Voron 2 right now. I think it's a 2.4 250 by 250, and it's not going very fast. I'm getting the parts printed. Should have them next week, and I can start putting it together. Ooh, a Keonce. What's the Keonce VR 3200? I love Keonce machines. Huh. I've been learning a little bit about optics, just because I had some ideas for making a 3D printed lens. And optics are complicated. Like, it makes me very much appreciate all the stuff my camera engineers had to do to be able to just have cameras that I buy and work well. They're crazy complicated, and the amount of precision required to get optics to work is like nanometers for a lot of things. Uh-oh. I put both of these on upside down. The threaded holes are on the wrong sides. What have I done? Oh, John, I know. I remember meeting you and discussing this. It's very... I mean, like, especially for small camera-sized stuff, like, I can only imagine it's even more precision. Like, there's all these, like, optical interference methods to be able to compare a reference shape to another shape. And you have, like, the optical bench set up with, like, lines that are formed from interference patterns from just, like, fractions of a wavelength of precision in terms of the... It gets crazy. Sounds fun, though. I'm sure it's rewarding to work on when you get it all working right. Okay, let's see. I always put things together upside down half the time. Oh yeah, Dangaranga. Have you done anything to address your air quality? Oh yeah. I mean, you saw my... the readings just dropped off a cliff and stayed near zero when I turned on my HEPA filter, so I think that's just the best solution for getting rid of particulate matter in the room if you can't vent it outside. Profilometers, they're very accurate. Easy to set up. Slow. Oh yeah, the that have like an actual physical probe. Those are also used in the dental industry. So I was actually concerned about the same thing. So TNX, you're saying venting outside is not good for, anyone outside. So I think filtering is best for everyone. Actually, a lot of the things when they're filtered outside, they get degraded by the environment and UV exposure. Like especially certain VOCs, I guess they get hit by by UV and get neutralized that way, or they like break down or oxidize or some crap. Anyway, so you just vent it outside and it'll probably get taken care of in the environment. But, you know, venting out little bits of microplastic, that's going to get in the ground, and I don't think that's ever really going to be addressed. So I agree. Filtering it on site is ideal, especially with HEPA filters. They're really not that expensive. I mean, I bought the most expensive HEPA filter I could find, and it was $500, which is less expensive than a lot of 3D printers. And they last, and they improve the air quality even besides just the 3D printer emissions. They're going to improve air quality from things like dust from outside or pollen or all sorts of stuff. So I really don't mind spending a little extra to invest in a HEPA filtration system. I could highly recommend it. UV exposure, then after it rains, the ozone takes care of the rest. Huh. I think there's this field called environmental engineering, and I used to think it was all about, oh crap. I used to think it was all about like, oh, save the environment, blah, blah, blah. We got to make sure not to pollute the waterways and all that stuff. But really, a lot of environmental engineering is workplace safety, and not just being friendly to the environment, but also being friendly to your workers in terms of the conditions that they're in. So that's like another dimension of environmental friendliness, is how it affects your employees. And if they're getting sick, then how are you like holistically being good for the environment when you're causing people to get sick? So workplace safety is really important. One way to think about it is if you could change your workplace so that it produced less pollution, like you cut the amount of pollution you have released into the environment in half, but you ended up like with a 10 times higher injury rate for your employees, like is that a trade-off worth making? Like at some point you have to factor in the fact that people getting injured is a bad thing. This is running a 200 by 200 bed. Oh yeah, TNX got you there. It's a 200 by 200 millimeter carbon fiber bed. This is the heated bed. It's completely made out of carbon fiber. And apparently you can scale it up to a 235 by 235. Like you could just take a Ender 3 bed and strap it on here if you wanted the extra build volume, which honestly I might do that. The stock build is kitted out for extreme speed. So all you high-speed printing people are gonna love it. Nice. Yeah, Mudatoyos all the way. Dave Ranga is another Mudatoyo fanboy. Okay, so I got one more piece to install here, and then we'll move on to the next step of frame assembly. I don't know how the people like Nero and Modbot do this. I get, man, like I just get so antsy when I'm building these things. I want it to be over. I just put together the FLSun T1 yesterday, and it took about a little over an hour to build, and even that I felt like was too long. Now here I am with my printer projects that are going to take a while. I imagine at this rate, this printer is going to take me 10 to 20 hours, maybe 15 to 25 hours to put together when all is said and done. Maybe 30. Like I'm pretty slow. I don't know if you've noticed. Okay, that's that. You get double ANSI building a printer for ants printer? I guess I would. Oof, that smells like some stuff. I probably should have cleaned these aluminum pieces off before I stuck the stickers on, but I think it'll be all right. In worst case, these little rubber bits fall off, and then I have to put some squash ball feet on here. Squash ball feet! Which is the best mod in the world for an Ender 3 style machine. Throw some squash ball feet on there. You'd be very happy with yourself. I'm going to, okay. Hello Glendon 3D. We're putting together the LH Stinger today. It's going pretty slow, and it's my fault, but we're gonna keep going. Nice. Feeling sturdy already. Nice little sturdy frame here. All right, let's go back to the assembly guide and see what's up next. I scrolled down too far. We're back up at the frame. Okay, we've got this far. Now time for the top bracket assembly. Let me see something here. Okay, so it looks like if I put the top bracket in place, it will block me from putting these MGN rails in. Or maybe it won't. Let's just get them at least somewhat put together. Okay. So I'm going to need 2 brackets. These guys, I've actually never used these in a design before because I'm never sure how much structural integrity these weird things actually add. These are some strange brackets that like sink into the something like that. We'll get it all perfectly lined up and installed here in just a second. Okay, so here's the top. Oh my gosh! everything's fine. Okay, so okay, now I guess this goes up here. Okay, so those are going towards the back. Yep, just like this. All right. Okay, I am not incompetent. I will manage to make this work. Okay, here's what we're gonna do. This is going in. This is going in up here. Yes. Highly competent. That's going in over here. And I'll put some of these little grub screws in place to keep it from moving around. If you close those, you won't be able to put the rails in. You'll hate your life trying to fit them in afterwards without removing the top. Yeah, I'm going to just get this so that it's like a lid that I can take on and off. I'm not going to get it fully secured, but I'll get the brackets in place at least. And then I want to properly clean out those rails before I get too far into this, because I want to basically go super fast, as is the kind of intended purpose of this machine. So we'll get to that later. In the meantime, let's see. I need to put one of these brackets in place. I know the brackets. Let's get the brackets. Okay, for wow, I'm blowing through these little plastic bags. That's the nice thing about everything being individually bagged. As you throw away little plastic bags, you know that you're making progress. Throwing away plastic is progress. Okay, so I need to find those little shims again. I must have shoved them away somewhere. Here they are, 6 by 12 by 1.5. What? Yeah. Need 4 of these. Pezliz, alright. Hey Pezliz, welcome. NK2 Kevin. I think your hair covering your eyes, I blame the hair for that drop. Yeah, that's probably it. I need to get a haircut. I'm just gonna grow it out because it takes forever to get long hair, and you just gotta go for it at some point. Just going for it. Full send. I let my girlfriend pick out all my hairstyles, so I really don't have autonomy over what's going on up here. Okay. I'm dropping things at an increased rate. Okay, there we go. What are blue snips? Yeah, fair enough. Well, I mean, she actually does want me to cut my hair, but I need to try some things. She actually told me to get a perm. What do you guys think of that? Do I need to get a perm? Get some wavy hair? Maybe bleach it bleached blonde? Yes. Yep, throwing away plastic is progress. That's the only way to measure it. I mean, that explains the current state of our, you know, how humans take care of the environment. Okay, need a couple more T-slot screws. If it's not going to be below a 5-minute bench, it's in vain. What is does anyone here know the speed benchy time for this design? I don't really know because I'm just focused on building it. A 5-minute benchy is pretty insane, guys. I don't know. I'd be happy with that. But also, being able to print things is fun. Cannot bleach and perm at the same time? Huh? Like, is it a fashion sin or is it like bad for your hair? Okay. Oh no. What to do? Brutalist looking printer? Yeah, it is very brutalist. So would you guys rather get this or a Prusa Mark IV? Because that's about where this thing is priced in terms of like a kit printer. That's about $800. I think we're getting there. Okay. 2 more of these. Oh, yeah. Lemur Hayes has some videos. You can click his profile in the chat and it'll take you to his channel. He's got some crazy stuff. I don't know if he documented his like benchy experiments on the Ender 3, but I know some people were getting pretty crazy with the Ender 3s. It's a really good design, just having the cross type setup where you have, you know, one extrusion here and one extrusion here, and then the frame to support the gantry. Like, it's a really optimal design, and that's why there's so many printers that follow that same layout. Like, you can say it's primitive or whatever all you want, but it's a good stiff design compared to a lot of other stuff out there. Okay, so Lemur probably disapproves of this, but I'm just getting this semi-assembled right now, so I can just take this top off and put it back on. Oh, jeez. Okay, yeah, so just semi-assembled right now. And then I'll go back in and clean out those linear rails. I think I might buy a what do you call it? The thing for cleaning out parts with ultrasonic, like the ultrasonic bath. I might get one of those. They're kind of expensive, but with how much I'm messing around with small parts and the fact that you can clean out bearings extremely thoroughly without having to put too much elbow grease into it is nice. Plus, there's all sorts of fun experiments I could do with it with 3D printed parts. So it's feels like something I should have anyways. All right, mostly there. Okay, this is nice. This is extremely sturdy. Feels good. It's like a picture frame, but extremely sturdy. Like, you could probably jack a car up on top of this thing. Okay, anyways, let's get the cross in here. So next up, we're gonna put the y-axis on. It's coming along well, up to speed. Yes, thank you, Lemur Hayes. I need the encouragement. Yeah, mainly I just want to get the frame put together today and just get like a general lay of the land. Then I'll start printing parts out, and I want to clean out these linear rails before I install them. They seem, you know, I bet the thing would run fine if I just put it together with these, with the stock grease in them. But if Lemur thinks I need to clean them out, I will clean them out. And especially since this printer is going faster than any other printer that I've used, I assume that the extra attention to greasing this thing properly is probably time well spent. Okay, so now it's time to get the y-axis on here. And speaking of y-axis, you could probably make like a 3-foot long one of these and just have like a meter long bed slinger. just for fun. Or multiple of these portals back and forth on this printer. Like, I just really like the way it's built up. Very sturdy. Okay, so let's see. One interesting note is that the way that these are oriented relative to like all the parts in the frame, on the Ender 3, the frame is built that it's like strong and skew. Like the vertical elements are wider than they are thick. Like they're wider in this dimension, like this. And I don't know why that is. On this one, it's built so that the like it's wider in this dimension, so that it's going to be more resistant to like this thing, what I call tombstoning, or you can think of it as like springboarding, where if you pluck this, it'll go boing. Versus on an Ender 3, I think that's the main way that the frame flexes. On this one, it basically won't flex like that. And then, like, I guess you might experience some flexing, like with this skewing, like this. But it's just so overbuilt, I don't think it's really going to be that much of an issue. And the tool head should be relatively lightweight, so it's cool stuff. All right, so let's put this on. Let's see. It might want me to do other steps before I do all this, but I'm gonna look at it. We're gonna look ahead. This is the part that it pains me. Getting all of these nuts lined up. On the Voron kit that I have, I'm putting together a Voron. For their linear rails, they have like a really long T-nut, essentially. Where was I? I got lost already. They have like a super long T-nut. So you just like slide it in all as one unit, versus this is a bunch of individual T-nuts. It's not the end of the world. I'm probably complaining about it too much, but it just takes a little longer to put together like that. And I'm happy to pay an extra $10 to get, you know, longer forms of these that I just slide in as one piece. Swap the y-axis with a different version. Okay, cool. So like later on down the line if I wanted to. Or maybe a belted version. X is very lightweight compared to the mass of the frame. Okay. Low center of gravity. Okay, let's see. Oh wow, my battery's dying. Hold on, let me get a laptop charger. Oh, I'm at 1%. We got this. Okay, so if anyone's wondering how much battery life a 2-year-old MacBook Pro has, it's exactly that. Pretty sure it was full before I started this stream. So maybe like an hour or 2 or 3 hours doing this live streaming stuff. Which seems a little short. Normally this computer lasts a long time, but there must be something about live streaming that's taxing on the printer or the computer. Okay, let's see. All right, I'm gonna get these brackets in place, these 4 on the bottom. This 1, 2, and I might as, oh no, those feet get attached to 3D printed parts. 3, 4. Okay, so I got 4 of those. They're all the same part, body frame joint. But they're the only joints left that I haven't used on other places of the machine. So, do-do-do. Okay. Time to consult the oracle on what type of screws I need. Okay, countersunk M4. Okay, so both of these are countersunk M6 by 14s. I'll just check on the back here. M6 by 14. Yeah. Okay, so I just need a bunch of countersunk bolts. That shouldn't be too hard. And they're assembled so that the rounded edge is down. Easy. So far so good. In terms of the quality of the kit, all the hardware seems to be pretty nice. The only issue that I had, or missing part, oh, it's a M series processor. It's the M1. Normally I can go like 6 to 8 hours of video editing, well, at least 6 hours of video editing without too much of an issue. But yeah, I think something about doing this live streaming thing is taxing on the computer. Like it never gets to rest, like it's constantly sending data. Okay, 1, 2, 3, 4. We'll get these put together. M series, and it died in 2 hours. Yeah, however long the stream has been. That's I think it just has to do with like the live streaming and running CAD and stuff. Like I've never had the battery go that low that fast. Okay, so we've got all this stuff. We're gonna put some more stuff on the thing. Pretty sure this gets flipped upside down. Let's see, John is asking what the belt size is on the y-axis. Oh, it looks really small here. No, I'm not clicking on the belt somehow. No, it's saying this is aluminum. I don't think we're using an aluminum belt, though. That would be pretty cool. I imagine it's a 10 millimeter. I'm not super familiar with this. But come to think of it, you probably don't need it to be super wide. The only reason why the belts are so wide on most bed slingers is because the bed's heavy. And on this, it's going to be pretty light. Yeah, this is going to be, this is 8 from here to here, so it's going to be 9 or 10 millimeters. 9. Huh. Yeah, personally, I'd probably would have made it thicker, but I will defer to LM's judgment, or LH's judgment. So, LH, are you pretty glad that FYSETC decided to pick your kit up? Pick up your kit and sell it to people? Like, has that been pretty cool? That seems like a pretty, kind of like a dream scenario for a 3D printer builder, is to have a company make kits for you. Thumbs down, no donuts this stream? Next time I'll get donuts. Don't you worry. I had healthy snacks today. We had a peach and some sweet potato chips. How much money? It's 800 for the kit. And if you act now, you can get $60 off with the coupon code that they sent to me, which is kind of cool. So, you know, it's probably free shipping. I don't know for a fact, but most places do free shipping, except Prusa and Bambu Lab. I think it's a good price point. Like, it's an alternative to the MK4. I guess the MK4S now is what it's called, and the P1S, the Bambu Lab P1S, and it's faster than both of them, and it's like fully open source. You can spec out and build it however you want. So I don't know. I think there's definitely a good argument for why you should get this machine instead of some others. Now, it does take a lot of time to build, but also think about the other printers that are similar to this in terms of the whole open source nature of it. You look at Voron kits, those are often in the thousands, like in the, over $1,000 to get them fully built. And I think they use a lot more plastic. This isn't enclosed, so it's like kind of a different target. But it's like super high speed. Should be able to get like excellent print quality out of this with how stiff the frame is. A lot of the issues you see with 3D print quality have to do with the frame not being perfect. But this is going to be like as rigid of a frame as possible. And once I get these linear rods cleaned up, I think we're going to be going pretty fast. Okay, I'm going to take these nuts out because I don't think they're going to stay in place. Let's see how we did. Yes, looks pretty good. I mean, this is built to a level of strength that it kind of reminds me of workout equipment. Like, this is not built like a 3D printer, if you ask me. It's super sturdy. I haven't got all the bolts tightened down, so I'm not going to like really jump on it. But first I need to clean off the linear rails, these things. I think I'm gonna pick up a ultrasonic bath to be able to clean them out. And then get these cleaned and lubed, put them in place. Then get all the printed parts made and, you know, assemble the little belt gearbox things. So there's gonna be a lot to do. What does the chat think of this printer? You're also not buying from a shady company with questionable business ethics. With Bambu Lab, 3D printing community would be wise to shift its focus and investment into another company, maybe. Yeah, I think being in a position where there's a complete monopoly over all the printers that are made probably isn't a good thing. From what I've been told by people I won't name, Bambu uses some same shady marketing tactics at DJI. What, like botted accounts and stuff? I've noticed that if you make any video that says anything other than Bambu Lab best company in the world, yay, you get so much more engagement. Like there's so many commenters. So I don't know. I think they're trying to discourage people from making videos that way, but me, I love the engagement, so I'll keep doing my thing. It's fun. Just don't take the content too seriously. We're just here to have fun. Okay, so Lemur's saying the specs and part quality for what FYSETC did are far above what the standard BOM is. Yeah, I mean, what about these hybrid stepper motors? Isn't the point of hybrid stepper motors that like at high speeds they're able to like continue spinning even faster? Or like they're smoother at high speeds? I don't quite understand that yet. I guess I think I want to do an episode where I look at that a little bit more. Yeah, Lemur Hayes, you've got quite the community, but I think the reason why people banded behind your project is that it was really cool and you put in the work to actually do the engineering and make sure it was going to be super high performance, which is, I feel like performance kind of gets set as like a secondary objective with some 3D printer projects. I won't name names, but sometimes like aesthetics or ease of, you know, sourcing or reduced part count gets prioritized. But I really think this is going to be the highest performing open source build. Well, I will caveat that actually the K2 design, that one is like definitely high performance. Not K2, the Annex Engineering K1 and K3. Those ones are definitely designed for high speeds and high accelerations in a similar way that this one is. But this is like coming in at a much lower price point, so it's making it a lot more accessible. Wow, DJI has a team of 30 full, allegedly, according to some sources, DJI has a team of people who are employed to smear the competition. That's crazy. Yeah, I mean, my gosh. People, just listen to you. Use common sense. If a lot of the comments on these Bambu Lab videos are just like super negative and hateful. Fortunately, I thrive on that energy, so I guess I'm the only person left that says anything other than complete positivity about Bambu Lab, which is kind of weird. Annex printers are the reference. Yeah, I would say so. They do a good job. Well, John, if there was any way to prove that, I'm sure it would be an interesting story. Who hired me? I don't know. I get fired by every 3D printing company that I work with because I don't really say positive things about the products universally. Every once in a while I'm impressed with the design, but the more stuff they send me, the eventually I'm going to get something I don't like. Oh, right, John, you work at a camera company that might have to deal with DJI's team every now and then. Ah, that's hilarious. Well, I mean, a lot of this social media, like, who are you going to trust? Do you want to trust someone who has a YouTube channel that, like, I don't know, has a reputation and a point of view? Or do you want to trust some random person on the internet talking smack about them? It's up to you. You make your decision. I'm just here to spread the news. Yeah, I don't know. I think a lot of people treat 3D printing companies as if they're people. And it's like, of course I'm not going to treat... I'm not going to be that critical to a person. And especially like these individual projects where it's just one person behind it, then, you know, I'm not going to just completely kick over their sandcastle and pee in their cereal or whatever. But when it's a huge company that's doing things, they have, I think, a higher burden to do things properly, ethically, whatever else. So I feel more okay about criticizing them. All right, I'm gonna put some of these screws away in the wrong bags just to make my life difficult when we start the stream back up, but it's all part of the fun. Actually, I'll just put all the loose ends in this bag here. So the M8 by 16 button head cap screws. All right, anyone have any other questions about this kit? I guess I'll take a look at the hot end that we'll be putting on here eventually. I think it's from FYSETC. FYSETC makes good stuff apparently. I mean, from my personal experience, I've had good experiences with them. Some people have had issues with their heaters failing. I haven't had that personally, so I can't really complain. But here we go. This right here. Now, apparently this doesn't infringe on... not legal advice, but apparently this doesn't infringe on the mosquito design. They came up with what they call a kinematic mount. I'm not sure how it works. And also, I'm not sure if I'm even correct in what I'm saying, but yeah, it's got the spacers, so it's similar to a mosquito. And it's got a pretty decent melt zone there. Let's see what nozzles we have. We have a 0.4, and that has to be a 0.6. It just has to be. And a 0.6, yeah. On this machine, I'll probably just go with a 0.4 because of how crazy the accelerations are going to be on this thing. I don't feel like I need to upsize the nozzle to get maximum flow. Maybe I'll go to 0.6, I don't know. Cool. All right, well, unless anyone else has a something to talk about, I think I'm going to call it quits for today's stream. Off stream, I'll get all my... okay. I'm going to get all my printed parts going and get my rails all cleaned up and ready to assemble. And I think the next build video will be a lot more in detail. What I'll probably end up doing is getting everything put together, including the belts, and then I'll save electronics and firing the machine up for the last video. So 3-part series, what do you guys think? Not using a 10mm nozzle. Well, I'm actually considering throwing a VZ Goliath on here because they have built-in compatibility with it. and I've got a couple of those laying around that I want to use on something. So it could be a good application here to get that 52 or 50 millimeter melt zone on that thing going. That could be pretty nice. Thanks for spending at least part of your Saturday checking out this printer. I think it's going to be really exciting. And like, obviously I get the printer for free, but that's not really why I wanted to be involved with this. I really appreciate what LH is doing. Like, if you join the Discord, the LH Discord, they talk about all sorts of stuff and all the work that they put into optimizing this and making it as fast as possible. So I really feel like this is an engineering forward team and an engineering forward project that's going to be able to do really cool things. And yeah, that's why I wanted to get one of these. So thanks for watching. Thanks to FYSETC for sending this over for me to check out. And thanks to LH for putting the project together in the first place. So, yep, I'm all done for the day, John. Thanks for joining, everyone. I'll see you.